The next feature we're going to look at is Spatial Join, and this is one we're really excited about. Spatial Join will copy attributes from one layer to another based on a spatial relationship between features on the two layers. These spatial relationships we've included are intersex, near, contains, within, identical to, has center in, and closest. So let's take a look at some examples. I've got the 13 provinces and territories of Canada. Here are some of the attributes. And then I've also got the populated places throughout Canada as well. And what I'm going to do is I'm going to take the 13 provinces and territories and find all of the populated places contained within each province and or territory. Okay, so here up on the toolbar, we've got our new Spatial Join icon. When I click on it, this is the dialog you'll see. So I want to add data to my provinces, and I want to add data from the populated places. And then I just select which spatial relationship I want to use. I'll explain what this precision slider is in a minute, but it basically controls how accurate your coordinates are. Okay, so I've got my spatial operation set up, but I also have some options to control which attributes are going to be joined to the provinces layer, and I can also modify some of the operations as well. So we can see here that the name attribute from the populated places, this is the name of all the towns. It's going to concatenate or join and make a list of all of the cities and towns inside each province. So I'm going to modify the size because I know that some of the provinces have a lot of cities, and I don't think 100 characters is going to be able to fit them all, so I'll increase the size to 100. You also have some options to customize how they are separated in the attribute value. Okay, I've got my population attribute. It's just going to create a sum total of all the population values in each province. The latitude and longitude, it could calculate the mean, but I don't need these, so I'm going to remove them. And you know what, I'll move the national capital and provincial capital attributes as well. I can also add an operation. So I've got my population set to create a sum attribute, but I could also find the mean population of each province. And so I can set it up by calculating the mean and controlling the number of decimals that'll be generated as well. So when I click OK, let's open up the attribute table for our provinces. And you can see that 4 attributes have been added to the provinces layer. I have name 1, which is essentially the list of cities inside each province. I have a population total. I've got a population average. And then it also provided a count, which is how many cities are inside each province. Next up, we're going to look at the within operation. So here I've got the time zones that we use in Canada. And this is what the attribute table looks like. And I'm going to be adding one or more of the columns to the populated places layer. And essentially it will tell me which time zone each of these populated places is located in. Okay, so let's open up Spatial Join. This time I'm adding data to populated places. I am joining data from my time zones. and I am using the within operation. Based on the two layer types, you will see the list change of the available relationships. And then it tells me it's going to collect attribute data from all area features on time zones that contain each populated place point feature and appends it to the populated places attribute table. So data from time zones is added to populated places if the populated place is within the time zone. Okay, so I've got my three attribute values that will be copied over, and I click OK. Let's take a look at the populated places attribute table, and you can see that my time zone attributes have been added to my populated place features. Next, we're going to look at the has center in. And this is basically, it takes a feature, finds its centroid, and determines whether it's located inside another feature. So for this example, we're going to look at the lakes throughout Canada and determine which province their centroid is inside. So I'm not sure which province this lake is going to be inside of. It could be either Alberta or Saskatchewan. So let's find out. So I'm going to add data to lakes. The data is going to come from the provinces layer, and I'm running the has center in operation. So when I click OK, select all of my lakes, and open up the attribute table, I see that many of the lakes are located within a province. Some of them are not. An example of that would be the Great Lakes. Obviously, their centroid must be inside of the United States. Thus, some of the joins did not work for those features. The one lake I wanted to take a look at, Lake Athabasca, and we can see that its centroid is actually located in Saskatchewan. That probably would have been my guess too. Okay, let's take a look next at the near operation. For this one, it's going to essentially draw a buffer around each lake and determine if there are any populated places within that 3-kilometer buffer. So let's take a look at our spatial join. So we're adding data to the lakes layer, and it's going to come from our populated places. When I select the near operation, I get to define a search radius. And this is basically defining how big that buffer is around each of the lakes. So I'm going to say 3 kilometers. So let's take a look at our lakes now. We can see that many of the lakes do have cities within 3 kilometers of a lake. And finally, the last example with this file, we're going to look at the closest operation. So I have this data set called world, and essentially it's various countries surrounding Canada here. We have Greenland, Iceland, St. Pierre, Miquelon, and the United States. And we're going to find which country is closest to each of the populated places. So let's open up Spatial Join. We're going to add data to populated places. The data will come from the world layer. And we are going to use the closest operation. So when we run that, we can see that many of the populated places are closest to the United States of America. A couple are closest to Greenland, and even some are closest to St. Pierre and Miquelon. The last two spatial operations that I want to show are intersex and identical to. So for that, I'm going to be using this file. For intersex, I'm going to find each of the states that every interstate runs through. Basically, which states do the interstates service. So if I take a look at my interstates layer, I am going to be adding a list of the states that it provides service to. Okay, so I'm adding data to my interstates layer. I am joining data from the states layer, and my spatial relationship is intersex. And I only have the one attribute. Let's make sure that we have enough space in our attribute field for the list of state names. Click OK. And we can see that all of our states have been added to our interstate features. So Interstate 95 runs all the way down the East Coast. And we can see that it services 16 different states, and I have a list of those states. Next, we're going to take a look at the identical to relationship. And if we take a look at the data sets I've got here, I've got two layers that represent the United States. This first one here has the state name, and this one has the population for each state. And really what I want is one layer that contains both the name and the population for each state. So I can use the identical to spatial relationship to sort of mash the two layers together and create a single data set with all of the data I need. So I'll set it to identical to, click OK, and now I've added my population data to my state name. We can see that all 49 areas have satisfied the join, and they all have a population data set. So it's a really handy tool for getting data from one layer to another based on the spatial relationship. You're no longer confined to using the join table, which required a unique attribute between your two data sets. Next, we're going to be looking at the precision. I mentioned earlier that it basically controls how precise the coordinate pairs between features have to be. If I move the slider all the way to the left, this tells MAPublisher that my coordinates between features only have to match to the first decimal place. If I move it all the way to the right, I'm telling MAPublisher that my data has to be more accurate. In other words, more and more decimal places have to match between the features. So I've got a data set here with lines or streets of Toronto, and I've also got a point data set. And I want to find which of these streets contain these points. I can see that two of them right off the bat don't even come close to a line, so I shouldn't expect all 4 points being contained by a line. But if I use the default precision to find which lines contain a point, I will see that 2 of my streets contain a point. I have Russell Street and St. Basil Lane. Now, if I undo that, set it up again, but this time I increase my precision to the highest level, I'm telling MAPublisher that my coordinates between the street and the point have to be very, very exact. So when I click OK and check my attributes this time, only 1 of my streets contain a point, St. Basil Lane. So there's obviously some offset or some inaccuracy between my line and my point here. We just wanted to offer a way to control how accurate your spatial join is going to be. And that's it for MAPublisher 10.6. I hope you enjoyed this video, and I hope you learned something.